Hi, everybody. So this is section 10.1, steps for a hypothesis test. So in this whole chapter is basically saying, we'll make a hypothesis test. And what I mean by a hypothesis test when it comes to stats is like, okay, given this data and you have this data and you get a conclusion based off this data, you say, oh, you find out that, this happens based on this scenario. Well, the question becomes, if you do this over and over and over again, will you get the same result? That's what this is all about. So, when it comes to credibility, like for instance, let's suppose like nowadays, right, we have this coronavirus happening. Let's say suppose someone comes out and says we have a vaccine for it. Well, if they only did it in one trial and it worked, but it didn't, if they did it over and over and over again and it didn't work, therefore, it actually, it's not going to, an actual portion for it, right? It's not going to actually help it. So that's what this is all about. So it's kind of the most basic scenario you can deal with now is what's happening, when it comes to it, right? But corresponding to figuring out a vaccine for it. They're doing trials and trials and trials and see, okay, does it actually work on multiple, not just one out of 100, on a variety of stuff. That's what we're going to be. So that's what it means by a hypothesis test when it comes to a stats portion, things like that. Okay, so hopefully you get an idea of what we're going to be dealing with. So and this, the cool thing about this type of test or hypothesis test, this you actually see everywhere throughout the portions: business, health, or nursing, anything like that. You always do a hypothesis test because you always want to test the trials you give it, especially when you go into research or anything like that. Okay. So before we begin, well, we want to talk about a couple terms when it comes to it. So the first thing is what an actual hypothesis in stats is all about. So a hypothesis is a statement regarding a characteristic of one or more populations. So it's really a characteristic describing or interpreting one or more populations. Okay, so when it comes to our proportions, remember our population parameters are the big three, just like for kings or confidence intervals, right? P, mu, and sigma, respectively. So those are going to be our population parameters. A hypothesis test is the procedure based on sample evidence and probability used to test statements regarding the characteristic or one or more samples. That's the actual survey. Actually doing the drug itself. Seeing if it works over and over and over again. Okay. Now, when it comes to a hypothesis test, we're always going to have one of the outcomes we got to test. So we're assuming the first part is called the null hypothesis. Okay. So the null hypothesis means it's a statement that does not change or no difference, and it's always assumed true. Okay. Unless otherwise dictated. So because our null hypothesis is always true, we abbreviate it as H naught is abbreviation for null hypothesis, and we have the parameter equals the value. So we're always assuming it equals the value itself when it comes to it. Okay. Now the alternative hypothesis is what we're actually seeing, does it work or not? So in the case of the virus, right, does the virus work or does the virus not work in the trials? Okay, so that's going to be alternative hypothesis itself. We're saying yes or no based off that. And the alternative hypothesis is signified as H sub 1. Okay, so it's a statement that when we're trying to find evidence to support, right? So in this case, we've got to find evidence. Does the vaccine work or not, right? That's what the whole thing of the alternative hypothesis is going to be. Now, when it comes to the alternative hypothesis, because it does not have equality, we're going to have three different ways of writing this. So this is, again, H1 represents no hypothesis, and the parameter is going to be bigger than the value, less than the value, and not equal to that value itself. Let me see if I can get the focus a little bit better when it comes to the camera. Let's see if I zoom in a little bit better. Focus. There we go. It's getting a little bit better to focus. The best is probably going to be, there we go, a little bit better. So greater than a value, less than a value, and not equal to a value. Okay, so the null hypothesis always has equality. That's the key thing. It must always equal a value. The alternative hypothesis, it doesn't have, so it's going to be either greater than, less than, or not equal to. One of the three alternatives. Okay, so if you flip the page, it gives you an example how we're going to find the null alternative given a statement itself. So example 1 says the percentage of students in a large statistics course taking notes with a tablet is at least 45%. So since we're given percentage, we know our population proportion, our population parameter is going to be P, right? Because we're given proportion. So that's the first thing we know. So the parameter is going to be P. The next thing we want to figure is the null hypothesis itself. Now it says, right, that null hypothesis always has equality. So what does at least 45% mean? Well, that represents P is greater than or equal to 45%, right, corresponding to the inequality. Now, since a null hypothesis always has equality, we're going to be assuming P equals 45%. Again, right, because a null hypothesis always has equality to that value itself. Okay, so that's how we get the null hypothesis. Now, the alternative hypothesis, again, because it says at least greater than, we have this happening. We just dock off the equality. So we have strictly greater than P. So P is greater than 45%. So this is how we write our null and alternative hypothesis itself, like this. You always have to have the parameter equal to the value. And again, right, all this means is a shortcut for null and alternative instead of you have to write it over and over and over again. Okay. It's not that bad once you get the hang of it. Let's try question 1 so you can see how this is going to work out. Okay. Says question 1 says, according to the Indiana University, the mean charitable contribution per household among households with incomes of $1 million or more in the United States in 2005 was $17,072. A researcher believes that the level of giving has changed since then. Find the null alternative hypothesis. Okay, so the first thing we want to do, like we did up here, is find what parameter are we actually doing. So are we doing proportion, mean, or standard deviation, right? That tells us the main focus. So if you notice in this question, we're talking about the mean charitable, right? It says right in the first sentence, the mean charitable. So we're talking about mean. So our parameter is going to be mu. So we know right off the bat, it's going to be mu equals something, and then alternative is going to be mu, less than or equal to some value. Right off the bat, we know that. Okay. So, well, what does the mean correspond to? So they give us the mean, right? It says, so mean was $17,072. So we're assuming that's still true, right? Because that course. So we're assuming that is still the same. That has not changed since 2005. Okay. Now, how to get the alternative hypothesis is, well, what are we researching, right? What are we actually trying to see if it's true or not? So in this case, the researcher believes the level of giving has changed since then. Okay. So does that mean less than, greater than? Well, I don't know, right? It could be less than this value, or it could be more than that value. However, come on, focus. There you go. But I don't know. Well, that corresponds to this not equal stuff. So I don't know if it's more or less, but I know it's changed since then. So that corresponds to me being not equal to $17,072. Okay. And that's it. That's how we find a null and alternative hypothesis. And that's it. Okay. So let's try the next one so you can see. So according to the U.S. Census Bureau, 10.5% of registered births in the United States in 2007 were to teenage mothers. Okay, so notice they give us a percent right off the bat. A sociologist believes that his percentage has increased since then. Again, find the null alternative hypothesis. Well, again, going back, right? So notice they give us hint, right? They believe the percentage. So percentage corresponds to proportion. So now we have proportion for this question. So we know our null hypothesis is going to be P equals something. And an alternative hypothesis, we got to figure out if it's less than or equal to that same value. Well, since we're talking about birth rates in the United States, so what's the proportion? We're assuming it's going to be the same, right? So the proportion is still going to be 10.5% because that's what we're assuming is true, right? The null is assuming is still that value. Now we go back to the claim. So according to the socialist, just like above, this person believes the percent has increased since then. Well, increase means that the real proportion has greater than now, 10.5%. And there we go. That's how we find the null alternative hypothesis. So why don't you guys quickly try question 3 and 4. Give you guys quick 3, 2, 1, and pause it. And then we'll do them together. So 3, 2, 1, pause. Okay, so hopefully you guys tried them. So question 3 says the standard deviation in the pressure required to open a certain valve is known to be sigma. So they notice automatically give you that. That's kind of nice, right? Equals 0.7 psi. Due to changes in the manufacturing process, the quality control manager feels that the pressure variability has been reduced. Okay, that's another key thing. Find no alternative. So this one's not too bad, right? They really tell us what it's going to be. So we know it's going to be standard deviation, so sigma. Okay. Now remember, for the null hypothesis, we're always assuming it's going to be the same. So we're assuming it's still 0.7 psi. Right? But now we go over here, well, the changes, well, what changes does it mean? So it has reduced. So reduced means less than, right? So now it's going to be sigma is less than 0.7, right? Has been deducted or decreased based off that information. Okay? So that's how we get question 3. And then finally question 4, the average time spent shopping online for Pacific retail is less than 30 minutes. Okay. So average, so we know it's going to be mu. That's kind of nice. So we can have our null and an alternative. Now let's see, this says less than, so we know mu is less than 30 minutes, right? Well, remember, unlike over here, right, they give us more information. This was just a quick little sentence, but this is enough just to give us a null alternative. Because again, when it comes to the null, we're always assuming it's the same. So we're still assuming it's going to be 30, right? We're assuming that. Now, the good thing is, right, they gave us exactly that, less than. So mu is less than 30 for our alternative hypothesis. That's what we're testing. Okay? And that's it. That's how we find a null alternative hypothesis. Hopefully it's not too bad. The main focus is firstly identifying what is your parameter, and then from there just breaking down what the inequalities would give you in the question. Okay, that's the first step of finding a hypothesis. That's just slowly just getting these two things when it comes to it. Okay. So now let's talk about a little bit more in detail what a hypothesis is all about, the breakdown of it. So it's actually done in 3 pretty nice steps. The first step is literally just finding the null and alternative hypothesis. So in other words, what we just did in the other pages, right? The second step is finding something called the test statistic and analyzing it itself, okay? We're going to talk about this in a little bit after we do this section. Come on, focus. Okay? And the very last thing is called the conclusion. So believe it or not, there's actually more writing than you may think going forward in these sections as well, but just like for it came to hypothesis test. Now, 1 wasn't too bad, hopefully. Step 3 is actually not that bad as well. So writing conclusion. So I'm actually going to help you guys out when it comes to writing the conclusion. So if you guys go quickly to your formula sheets, so these ones here, and if you go to the very end, we're going to follow these steps when it comes to writing our conclusion. Follow this nice little flow chart when it comes to it. So a lot of it is just answering questions and then just going which one is actually going to be true. It's one of very easy, and we'll do some practice runs in a little bit as well. Okay, so don't worry about that. Okay, so that's going to be using the very last page to find how to write our conclusion very nicely. Okay. Right, so in the next video we'll talk a little bit more of the errors and going forward on that as well.